Okay, hello everyone, and welcome to the Israeli chapter part in the OWASP all-day conference. Thank you to our friends in India, Vandana and her entire team for a wonderful part of their conference. And I'm happy to be here today with Omer and Michael. So without further ado, Michael is going to be our first speaker. Michael has more than 13 years of experience in application security, and today he's leading the security architecture for Tufin, where he's in charge of their entire application security for all of their products. Michael is going to talk to us today about CSRF attacks. So Michael, please take this from here.
Okay, thank you. Thank you everyone for joining. I will start to share my screen. Okay, okay, I hope you can see my presentation. Can you see it? Can I proceed?
Yeah, please go ahead. And by the way, all of our viewers can post questions on the chat in the YouTube stream, and Michael will be answering them either at the end of his session or at the end of the entire session after Omo speaks as well. Michael, please go ahead.
Okay, thank you once again. How same-side cookies making the world a safer place, and what we will see today. We will recap on CSRF attacks. We will talk about synchronizer pattern, and we will talk about same-side attribute and its supported settings. Then we will talk about new cookie policy and its best practices. I have a lot of years, couple of words about me. I have a lot of years in security. I have 7 years as lead security architect. I do like to do presentation. You can read my presentation at my blog. And a couple of personal words. I like to travel, to read books, and to listen to music. And a couple of words about Tufin. It's market leader security policy orchestration. We have products that will allow you to handle security management in hybrid environments. And also we have secure cloud products that will allow Kubernetes and cloud traffic. In addition, we have free firewall change tracker tools that will allow to manage your firewall management changes for free. Okay, what is CSRF attack? Who remembers CSRF attack? It's pronounced in CSRF and was introduced in OWASP top 10 and dropped out from last top 10 2017. It's serious security problems that should be handled. And CSRF is an attack that forces an end user to execute unwanted action on web application in which they're currently authenticated. This definition from our OWASP site. And it will allow, for example, to an attacker to transfer money from unprotected bank application from your account to his account. Let's see first demo. During demo, okay, I use the applications that based on Spring Security, okay, Spring Security tutorial, and let's say that I want, I will even log out, and I will go and I will open my application in the morning, and I want to check my balance, and I want to put additional $20, and I will authenticate using user root koala. Okay, and I will put additional money. Now, during my coffee, I will open some newspaper or forum or whatever in the tab. I will open it once again. I will open it once again. Okay, I will try to check my balance once again. Oops, I have only 100. Where is my money? My money was transferred by CSRF attack. And let's try to understand how it is possible. Left, open F12. and let's see our traffic. We can see that our application after authentication uses this cookie, started FC and ended E99. Let's try to see what happens during if attack if we open the same F12, and let's see that now we use the same cookie. It means a browser sent to the same cookie. Why it happens? Let's look for a second in our CSRF attacker application. You will see that we have request. This request sent to the same bank account, and we have some basic HTML JavaScript that will allow to use, to run this HTTP request during load page. But basically, it means that we have HTTP request from the page to our bank. And since a browser has authenticated user, it sends authentication cookie to this request, and this request is successful. This called CSRF attack. Let's back to them presentation, and let's see it on slides. So first we authenticate against into the site, and then a cookie sent authenticated cookie to a browser. When we visit malicious site, forum, anything else. What happens next? In a browser, you will have JavaScript or any other malicious code, and this malicious code will be able to attack the trusted site. Why? Because a browser will send cookie. How to protect against CSRF attack? First of all, we can use synchronizer token pattern. Okay, it's very old and very known pattern. Let's see how it works. It's just a reminder. So first of all, server generates a token and it sends a token to a client. Usually it's sent in some hidden way. And when during a submit, client submit a form with this token. And server validates the token during client submit. And what happens next, server marks the token as invalid, and the token will be not be able, you will not be able to use it once again. Since the token will not be sent over cookie, an attacker will not be able to attack server. So pros of this synchronized token pattern, it's very strong pattern. It protects very good against CSRF attack. It will require modification of clients. For example, if you use framework like JSF, you will not need to do it, but if you will use, let's say, Spring Security, you will need to change your clients. So you will need to invest some effort to allow this synchronized token pattern be part of your product. Let's talk about the same site attribute. What is same site attribute? Same site is a cookie attribute. It's similar to HTTP only or secure or similar cookie attributes. It was introduced by Chrome in 2016. It prevents a browser from sending a cookie along with the cross-site requests. It adopted by all major browsers by the end of 2017. In the beginning, of first adoption, it supported only two attributes, two settings, strict and lax. What is strict? Strict browser does not send a cookie to other site in all cross-site strict context, even when following link. Okay. Lax value. We have only a couple of use cases, only 3 use cases, 3 get cases. I mean HTTP GET request, link, pre-render or form GET, and only when you have top level GET request. It means that you change URL in your address bar. I will show in the demo, but this is very important. Only 3 use cases and only with top level GET request. Okay. So what about new cookie policy? New cookie policy was introduced by Chrome in May 2019. It was planned to be enforced in February in Chrome 18, but it was postponed due to COVID, due to coronavirus, to July 2020. It will be enforced in Chrome 84. So you see that coronavirus, has very big affected area, even it affects same-site cookies. What is this new cookie policy? If the same site attribute is not configured, the default setting is lax. And now we have support for three settings. Strict lax as before, an additional setting known. In case of known, it enables browser to send a cookie to other sites. It adopted by all major browsers, and very important, the policy is not enforced by default. As I said before, will be enforced in Chrome. If you've seen details, you can look at this great site that I personally like it. It allows to use it, and you can open the site and to go to see when same site default will be implemented, and you can see that it will be implemented only in Chrome. By the way, what we have here? We have here a couple of colors. Color green means it is implemented. Color red, it does not implement it. But let's say Firefox, if you will open Firefox, can read that can be enabled. Like that's back to big picture. It is implemented only in Chrome. It's in Opera and in Edge that use Chromium engine. Okay, so it will be enforced. And what about Chrome? Let's back to presentation, and you can see that you can even configure it now. You can configure it now. You can configure it Chrome. Go to Chrome configuration, Chrome Flex, and to enable these settings. And in Firefox, you will be able to go to these settings and to enable using this to this URL, and then configure the settings. Okay, let's back to our demo. Okay, and let's open configuration. Let's look for logs. And same site by default cookie, let's enable it. By default, it's not enabled, and we need to relaunch our Chrome. Let's see what's happened now. Now, as you remember, we have only 18. Let's say I will put it once again. I don't know where is my money. I need in my account 200. Now I have 200. And then I'll still, during my lunch, I will go to the same site because I don't know that this site tries to attack me. I try to go to the site. Let's check. You see that we have the same 200. Let's open our traffic, our network traffic, and let's try to understand what happens. Okay, let's try to see, and you can see that cookie is not sent. A browser will not send any cookie, and the request will be redirected to login form. So using this simple setting that we have configured, okay, and using the new cookie policy that will be enforced by Chrome, we are able to protect our site against CSRF attack. You see how same-site cookie make our world a safer place. And I want to use this opportunity, I want to take off my hat and want to thank Chrome to continuously improvement of security in internet. It's a very big step to provide a protection against CSRF. Let's try to understand why this policy is so important. All cookies without the same site attribute now considered as lax. So maybe you have requests from your application to other application, and this request will stop to work. HTML frames that are opened via link will not work because it's not top-level request. Applications, if you access other application via AJAX request, will stop to work. So what should you do tomorrow in addition to wash hand? As you know, usually we need to wash hand we are in COVID-19, but what we may do tomorrow to relate it to same site, I strongly recommend to set same site attribute explicitly. In this case, you will apply protection to all browser at once. Okay, you will not need manual configure same site for every browser. And of course, you don't wait for browser to enforce it. As you remember, in the beginning, it was planned to February, not it's postponed to July, but in any case, it was only in Chrome. This is an example how you can set it. By the way, I strongly recommend, in addition to same site, to use security to HTTP only. It's related to security, security organization. But in any case, this is example of how to use same LUKS. In addition, even you will configure it, you need to ensure that you are prepared for Chrome upcoming new policy. Chrome is a very popular browser, and you need to ensure that your application will work well in Chrome. So what you need to do, configure Chrome new policy as I showed in demo, and test your application. You are more than welcome to use developer tool to see console warning. Now let's try to understand best practices. What is good to know, to use in what attribute settings better to use in what case? Let's start from strict. When should you use strict? If you have a single host application and you doesn't have links to other hosts. Okay, you have some caveats. Links to an application will not work even for authenticated user. I will provide an example. For example, you will authenticate for your GitHub account, okay? And you receive email with link to your GitHub account. When you press a link, you will need to provide your credentials once again. Why? Because in case of strict, browser will not send cookies, and you will need to provide credentials once again. Your single sign-on protocols like OpenID Connect to SAML will not work because it requires redirection and browser will not send cookies. But in any case, if you have like bank application, that bank application don't expect, let's say, links to other application, maybe strict is good for you. Okay, let's go to LUKS. When we should use LUKS? Okay, my opinion in all other cases. I mean, if your application can send cookie according to what I have described before, only 3 use cases. I mean, let's say you connect to other application via top-level request, via top-level GET request, so it's good for you. Because cookie will be able, browser will send cookie in GET request, but it will block it in POST request. We have one caveat. You should ensure that HTTP GET request will not change, do not change the state of your application. I will show an example. If I'll take this URL and I will open it in a browser, once again, it's a GET request, but it's top-level request. What will happen? You will see that my money was transferred to another account. This example, change state, it means it's allow transfer money via GET request. And you can see that cookie is on the place. It means even we have configured LUKS, even we have enabled policy to send LUKS to all cookies, our application by mistake changed a state with GET request. It means we have supposed that we have protected against CSRF attack. In reality, we do not have such protection because we changed a state. So once again, ensure that your application don't change. If you need to change a state and you have GET request, your application should drop this request. Then we should use none, and it should be used only as a last resource. And when you don't have any options, maybe you in transition from none to everything else like LUKS. Okay. You should understand that we have a couple of caveats. that none is only valid when using HTTPS. HTTPS, it probably should be default when you develop an application, but if your application uses HTTP, you will not be able to use none. In addition, it will not work with all browsers, okay? And if I will open this link, I hope the second time the link will work, okay? So what happened now? If your customer use or you use very old Firefox browser like 59 or 15, none will not work correctly. You will have unexpected behavior of a browser. Maybe it's not a real use case, but you need to understand that this is a limitation to use none. And okay, the same site attribute, pros and cons. So pros lets you easily protect from CSRF attack. Cons, its request to other application may stop working. If you have iframe or anything, as I have described before, it may stop work. Or in addition, for very sensitive application, it should be implemented, must be implemented as an additional layer. You still need to implement the synchronizer token pattern, and then you will be able to implement the same site attributes. You see, it was almost end. You have takeaways. You know how to protect against CSRF attack using the same site cookie attribute. You understand the new cookie policy and know how to prepare for it. And most important, you understand how same site cookie makes the world a safer place. I want to thank you for your time. Sorry once again for interruption, and you are most welcome to read my post or follow me on Twitter. And questions? Do you have any questions?
Okay, Omer, are you ready?
Okay, so you're gonna roll into the next talk then?
Yes, I think so. I think that a lot of people already know Omer Levi Chevroni, and if you don't, then Omer has been developing software since he was 10 years old, and he has been doing it for quite some time since then. Today he's working at Snyk, which is a great company for developers, and I'm sure that all of our friends in OWASP already know it. He's doing DevSecOps over there. And other than that, Omer is contributing in other OWASP projects, and he's doing a lot of amazing stuff, which he will tell us about in a minute. Today, Omer is going to talk to us about vulnerable dependencies. So at this, I'm going to leave it to Omer, and I will remind everyone that they can ask us questions over in the YouTube chat, and Omer will be happy to answer them at the end of his session.
And I can say that Omer is awesome in general, without all the resume.
I'm flashing here, but I'm not sure everyone can see it because of my screen color.
It's not PC these days.
Yeah. So thank you for the kind word. It was a bit embarrassing to hear all that here. So hi everyone. Good morning or evening or middle of the night, wherever you are. Today we're going to talk about two things that I really like, dependency management and how we can make it better. And before we talk about dependency management, let's start with talking about why do we even need to talk about dependency management. And I'm sure some of you are already familiar with it, but let's start with some fun question. What is the most dangerous command you can run on your local machine? Give it a few seconds, think about it, and just try to think, because it's going to be hard to hear your answers. So there are a lot of dangerous stuff you can run on your machines, but one of the most dangerous one is npm install. And if you don't agree with me, let's talk for a second about what happens when you run npm install. Basically, it's going to install all the packages that are defined by the repository you just forked. But it's not only those dependencies, because each one of them can have its own dependencies, and they can have dependencies. This is just some stats from the last sneak of open source support. We are working on a new one, so stay tuned. It will be very interesting. And what you can see here that in NPM, Ruby, and Maven, most of the dependencies are indirect, meaning dependencies comes from a dependency that you added that has its own dependencies. So when you run npm install, you are going to install a lot more dependencies than the one you already know about. And some of them could be vulnerable, as I'm sure some of us already know. Now, this is not something new, and a lot of people are talking about it in the recent few years. We can see that we are going to still have a lot of high vulnerabilities, and luckily there are good tools to check out for such vulnerable dependencies, like Snyk, OWASP dependency track, or dependency check, which is an awesome open source project, Black Duck, or White Source, and you can use each one of them to find vulnerable dependencies, or just anytime you run npm install. This is an example from OWASP Juice Shop. Basically, just by installing npm install, you get feedback if you have any vulnerable dependencies. So luckily, we get to a state where in 2020, it's really easy to find vulnerable packages. There is no excuse to not knowing what is there, but it's still very hard to mitigate all those vulnerabilities. And this is basically what I want to talk about, because we're already beyond discovery. We all know how to do that. But what about triaging? And this is where things get interesting. And I know that because this is basically one of the things I do for the last 3 years, give or take. And because I started as a developer, and this is what I always like and still doing, build stuff. But in the recent 5 years, I did a shift to application security and AppSec. And in the recent month, I moved to joined Snyk, which is now I'm working in the business of vulnerable dependencies. So it's actually a good time to remind that. And in the field of AppSec or DevSecOps, what we basically try to do, because we're already past discovery, is trying to think how we can make this process less painful. So first, let's do a quick review of the process. If you're a developer, you'll probably hear at least once in your time an AppSec engineer shouting at you, please remediate all the vulnerabilities. Is that this simple? Let's see what we need to do. We first need to triage, decide if this is a real issue. Sometimes it's an issue that might not affect us, or we decide not to fix. Then we need to figure how we want to update. The vulnerable version, we know what it is, but we need to decide to which version we need to fix. If it's a major or minor update, we need to open a fix PR to upgrade it, including the log file, wait for the test. If we have a lot of tests, it's going to take some time. Then we need to deploy it, and of course pray, because we just deployed something to production and we all know it is going to break. Now imagine doing this process for each one of your 100 of microservices each time there is a vulnerable dependencies. It's just too hard to do it. And this is why we usually want to go with automation. For example, if you use GitHub, and I'm sure some of you heard about GitHub, GitHub can automatically open security updates for some of the package management, not all of them, and at least solve the part of figuring the update path. So they will do that for you, but it's still not enough. You still need to review the PR, wait for the test, merge them, deploy to production, and of course, monitor and pray. Because each time you change a dependency, you change the code running in production, and it will break stuff. So this is why some companies was able to get to a fail automation, and it's really hard to get there. Basically, what we need to do is very hard. We need something that will auto-merge a PR, GitOps, or any other mechanism that will deploy to production each time we merge to master. And then we want something that will do canary deployment. We release the changes only to a small subset of our users and slowly roll out it to all of them. And then we want something that will monitor the production and do either auto rollback or monitor or whatever if there is an issue with the changes. And we might even go even further and decide that we want update dependencies in general using Renovate or Sneak or Dependbot that will upgrade dependencies if we have any new version. So that the next time we will have something vulnerable, it will be a lot less harder to remediate it. But this is still not perfect. This is an example for Camus, and you can see how many PRs we had just from Renovate to upgrade dependencies. Now, I multiply that by 100 microservices, and I imagine each one of these PR doing a deploy to production. This is going to create a lot of noise for your developers, as some of those PRs, and I know from experience from Camus, going to break production. So even if you had really, really good automation, fixing all the vulnerabilities is still hard, and we still have work to do, because each time we need to roll back, we need to do manual work to understand what's broken and how we can do it better. And this is why we want to go with prioritization. And if you are anyone from AppSec or InfoSec, please go close your ears. But we are not going to fix all the vulnerabilities. There are some vulnerabilities we are going to just leave there and be fine with them. And this is something that might be hard to hear, but this is just the reality. We can't fix everything. Take this for example, something from Sneak, from JuiceShop, as you can see. This is high severity, so we probably should fix it, right? But this is not necessarily the answer. There are some factors I put here. For example, maybe the endpoint, maybe this service is not exposed to the internet or not handling PII. So maybe we don't care about most of the vulnerabilities, or maybe there is no known exploit for it, which is very interesting. This is a feature of Sneak. After all, there are a lot of vulnerabilities out there, but not all of them has public exploit in ExploitDB, for example. A public exploit means you can go to ExploitDB, download a script, and just exploit it, which is a lot more dangerous than some report on HackerOne, which you need then go and actually make it exploitable. So this is something else we should consider when we talk about a vulnerability. Does it has a known exploit? And this is all lead us to say that severity is not the same as risk. And what we should care about is how risky this vulnerability is. And if we're already talking about prioritization, maybe we don't need all those packages. If you are in the Node.js ecosystem, you're probably familiar with a lot of small packages that basically do 3 or 5 lines of codes. And each one of those packages you install, it's a package you need to maintain. So sometimes it might be better to just copy the code to your project instead of using a dependency. And of course, if you copy the code, give a reference. Yes, it has the risk that if there is a vulnerability in this package, you will not know, but it's a risk worth considering. And finally, now that we heard prioritization and we have automation, it's time to talk about visibility. After all, we can't manage what we can't measure, as we all know. And we can start collecting metrics. For example, we can start to look on all the vulnerabilities we know and split them by a service or by a team or but whatever works for us, and start look on the trends and look on how things are going. We can start to measure how fast we are, how much time it took us to remediate from the minute we know about the dependency. Or if we talk about risk in the previous one, we can look on the average severity or average risk, and we know where we should spend our time as AppSec team, with which team we should work in order to where we should put our efforts. This is a good case to use OWASP Defect Dojo. It's another flagship OWASP project that could help you track those data and show them in various reports and make it easy to make sense in all this data. And once we have it, we can start think how we can use it. For example, we can do a monthly Hall of Fame, or depend on your company culture, we can use it to either bottom up, share it with team and ask them to take action, or top down, send it to all managers and ask them to make sure their teams do something about it. It could even be part of our SLA, something we use regularly and check. And those are all various ways to use it. So these are just examples. And now it's time to talk about communication. And communication is really interesting because we always need to remember who we are talking with. And this is something we usually tend to forget, especially as AppSec. We are not speaking to our fellow InfoSec engineers, which understand everything. We are talking to developers or product managers or even stakeholders. So giving them something like that is not useful. They don't understand it. We need to give them something with business impact, like hackers can still use their data. Or if we have a business requirement to buy apples and we have a denial of service issues, it could affect this business requirement. And when we connect communication to what we talked before about prioritization and metrics, it all makes sense together. And now when we start wrap up and look about the things we talk, automation is our first line of defense, but it's not enough. We need to prioritize what we need to focus, make sure we have good visibility to it, and that we communicate well in a language that all of us could understand and not just those of us who speak the InfoSec language. But I'm sure you have questions about other type of vulnerabilities. For example, I'm sure some of you are already familiar that Docker containers also has vulnerabilities, and a lot of them. And the same is true for virtual machines. There are stuff installed them and could be vulnerable. And those areas are a lot more challenging because you have a lot more vulnerabilities and they make a lot less sense to your developers because they didn't install them. We need to use the same principle, but it's going to be harder. The prioritization will be harder, the communication will be harder, and the automation, because not everything has a fix. Any questions? Okay, so thank you, everyone. I will be on OWASP Slack or on Twitter. If you have anything to share, I will be happy, especially if you want to share about your journey and how you handle these massive vulnerabilities. So thank you very much, and thank you to Shira and Ori and all the OWASP staff who work on this amazing day.
Thank you so
Awesome.
much, Omer, for a great talk.
I may ask, maybe I will ask one question for me, with your
Yes?
permission.
Yes?
When I can use Lux, and as I said before, I recommended to use Lux even and without waiting. So you can open this, once again, this wonderful site, and you will be able to see that the same site Lux today is supported in all browsers, except, let's say, Internet Explorer. But if you will configure the same site explicitly as according to this example, what you will have very reasonable, very good protection against against CSRF attack, and it will work with any browser that listed here, except Internet Explorer, and you don't need any configuration. This is everything from my point of view.
Okay, great. Thank you so much. Thank you, Omer and Michael, for your wonderful talks and your contribution to OWASP All Day. Ori, some wrap up?
Not a lot. I enjoyed the the last day very much, the hours at least that I could see. And I am happy that we got the chance to also participate and add that two great lectures from Omer and Michael. I want to thank OWASP for the opportunity, and that's it, I think.
Excellent. So at this, I think we're going to continue and move on to OWASP Ukraine and hear their talk. Thank you, Grant, for all your help at the at the back end of this day, switching between the speakers and the decks, and doing all of this work. We thank you for your help and support.
Absolutely a pleasure. Thank you, Sharon. Thanks,
Thank
guys.
you very much.
Right,
Thank you,
and
guys. See you soon.
Bye-bye.
Thank you, everyone. Have fun.
Have fun. Bye.
cheers, guys. And we will be up with OWASP Kiev, Ukraine. After this session, it'll start at the top of the hour so they can get ready. So this gives everyone a chance to take a bit of a rest break. Go get a cup of coffee if it's early like it is here. And we'll see you back at the top of the hour. Thanks, everyone.